In this lesson, we're going to be talking about slope-intercept form of a linear equation. As we talk about linear equations this unit, we're going to talk about three different linear equations and their forms. One is called the slope-intercept form, another is called point-slope form, and another is called standard form. So there's three different forms in which you can see the equation of a line. We're just going to go ahead and talk about slope-intercept form today. And the formula for slope-intercept form is seen here. Y equals mx plus b. The m represents your slope of your line, and the b represents your y-intercept, so where the graph crosses the y-axis. So given this first piece of information here, let's go ahead and determine the linear equation given this information. They give us that the slope is 4 and the y-intercept is -2. Remember that the slope is going to represent our variable m, and our y-intercept is going to represent our variable b. So all we're going to do is take those given numbers and substitute them into our formula, giving us y equals 4 times x minus 2. Now, you'll notice that in the formula for slope-intercept form, it's actually a plus sign. But we don't want to actually write plus -2. We know at this point that when you have a plus and a minus next to each other, you'll always make sure you write the minus. So it's just going to be y equals 4x minus 2. And there is your equation of your line in slope-intercept form. Now let's go ahead and take a look at two examples where we're actually given the equation and we want to graph it on a coordinate plane. So the first thing we need to do is pull out those little bits and pieces. We need to pull out the m and we need to pull out the b. So in this case, the slope of our line is going to be equal to 2. And the y-intercept of our line is going to be -3. So to graph this on a coordinate plane, we always start with our y-intercept. So let's go ahead and grab our y-intercept and go ahead and plot -3. And when we graph, we want to make sure we have nice dots that we can actually see. And you're going to see how we're going to draw the line in a second. My slope is 2. Now remember, slope is a rise over a run, right? And if my slope is 2, I actually kind of have to split that up into both the rise and the run. So I'm going to split that up into 2 over 1 to give us that fraction. And what I'm going to use that for is my rise and my run. I'm going to start at my y-intercept and I'm going to rise 2 and I'm going to run 1 and I'm going to draw a little dot. I'm going to rise 2 and I'm going to run 1 and I'm going to continue that pattern all the way up off of the coordinate plane as far as I can go. You'll also want to go in the other direction as well. Now to go the other direction, you just have to kind of think about your slope in a different way. We're actually going to rise -2 and we're going to run -1, still giving us a slope of 2. So rise -2, run -1 to give us that last coordinate. Now the most important part of the line is the actual line itself. So once you've drawn all of your dots in, let's go ahead and draw our line. We're going to start a little bit off of the coordinate plane on one side, and we're going to make the straightest line we possibly can through all of those coordinates, taking us off the coordinate plane on the other side. And we always end off by drawing little arrows at the end. And what these arrows mean is that this line is going to extend forever in both directions. And we talked about that in Unit 3 when we talked about function rules. And that's exactly what this is. It's a linear equation, but it's also a function rule. Let's look at another one. Let's go ahead and look at y equals -2/3 x plus 1. First thing I want to do is determine my slope, and my slope here is -2 over 3. And my y-intercept is +1. All right, now there is a very important thing I want to talk about when it comes to slope, and I always get this question, so I think it's worth talking about. So do you see how in this example here, the negative is out front? So it's actually written like this, -2 over 3. That means the same thing as this, -2 over 3, and it also means the same as this, 2 over -3. All three of those are equivalent statements. So whichever way you decide to write it, it all means the same. It is not the same as this though. It is not -2 over -3 because that would give us a positive slope. So that does not work. So whatever way you write it is perfectly fine. All right, let's start with my y-intercept. Y-intercept is +1, so I'm going to start with a dot there. And then I'm going to use, I'm going to go ahead and use the one that I wrote here, m equals -2/3. So I'm actually going to go down -2, and then I'm going to go to the right 3. There it is. And I'm going to go ahead and do that same pattern again. Down -2 to the right 3. Notice how the line is creating a negative looking slope. You want that. I'm going to go in the other direction now. I'm going to go up 2 and I'm going to go to the left 3. And I'm going to go up 2 and I'm going to go to the left 3. Notice how it creates a very nice line. So I'm going to go ahead and draw my line through those coordinates as straight as I can. Use a straight edge if you can, with arrows at the end. Notice how the slope of this line is negative, and notice how the graph actually looks like a negative slope. They should match up if you did it correctly. Okay, now let's go ahead and talk about what happens if you're given the line. How do you actually figure out what the equation is? It's kind of like you're going backwards. So let's go ahead and look at this first line. And I want to determine both the slope and the y-intercept just by looking at the line. Let's look at the slope first. What is our slope here? It looks like we're rising 3, and we're running 1, 2, 3, 4, 5, 6. So my slope is 3 over 6, which of course we can simplify down to 1/2. My y-intercept is right where that graph crosses the y-axis, so -1. So I can rewrite my line here as y is equal to 1/2 x minus 1. And that's how you take it right off of a graph. Let's try another one. Again, I always want the slope and I want the y-intercept. If you want to start it with the y-intercept first, that's fine. You can see our y-intercept is going to be right here, and it's going to be at -2. And the slope, let's see what it is. Let's rise -4, and we're going to run 3. So that's -4 over 3. And we're not going to simplify this down. We're not going to write it as a mixed number. We're just going to leave it just like this as an improper fraction. So y is equal to -4/3 x minus 2. And that is the equation of your line. Okay, we're going to do one more here, and this one's kind of cool. Let's figure out what our slope and our y-intercept is. Oops. So my slope and my y-intercept. So let's see what the slope is first. It looks like it's 4 over 1. And we know that 4 over 1 simplifies down to 4. So that's the slope of my line. My y-intercept is at the origin. So my y-intercept is 0. So to write this, I'm going to write it like this. Y equals 4 times x. And that's it. I'm not going to write +0. And this is a very special type of linear equation. This is actually called something, this is called a direct variation. And we'll talk about that a little bit later. But this is a direct variation equation. Direct variations always go through the origin of the graph. Okay, we do have these special graphs. I like to call them special graphs, where you have your vertical line and you have your horizontal line. And when we write these in slope-intercept form, they're not actually going to look like they're in the form y equals mx plus b, unfortunately. When you're writing the equations of these lines, they're always going to look the same, no matter what form you are actually asked to put it in. So the equation of this first line is going to be this. X is equal to 1. And here's the reason why. Do you notice how this graph is crossing the x-axis at +1? And that's why. This other graph over here will be y is equal to 1, because the graph is crossing the y-axis at 1. And so anytime you have a graph like this and you're asked to put it into slope-intercept form, this is how you would do it. A good way to remember this is a little trick I always like to teach. with the first one here, x equals 1, do you see how the variable x has all these little v's in it? Well, v is for vertical, and it'll always give you that vertical line. And likewise with the y, if you flip the y upside down, it kind of looks like an H, and H is for horizontal. So if you have a vertical or horizontal line, that'll help you remember how to do that. Okay, a couple more things here. Using the provided information, determine the equation of the line in slope-intercept form. This is where we start getting into the details here. Now, I'm given in this first example a coordinate point and the slope of the line. So if you kind of picture what's happening here, you actually have a graph, and you have the point 3, 4, which is about right here, and then you have the slope of the line, which is 1/3. And they're asking us, what is the equation of that line that has that slope and passes through that point? That's what the question is asking us. And here's how you actually determine this. So we have a point, we have a slope. We're going to actually use the formula y equals mx plus b to figure this out. Do you notice how I have an x and a y given? That's going to represent my x in my formula and my y in my formula. I'm also given the slope. If you have 3 out of the 4 variables, you can solve for the 4th. So let's go ahead and substitute these values into our formula. I'm going to say that 4, that's my y, is equal to negative 1/3 times my x value plus b. We actually don't know what that is. So let's figure out what b is. So 4 is equal to negative 1 plus b. Now solve for b. Add 1 to both sides. My b is equal to 5. Now that's just my y-intercept. Now think about it. I have a slope and I have a y-intercept. Once I have that information, I can put it into slope-intercept form. So y is equal to negative 1/3 x plus 5. And there's the line that's going to pass through that point and have that slope. Kind of neat. Now this is a procedure that you're using, and you want to make sure that you practice this procedure. Now what if I gave you some other information? What if I said I'm giving you 2 points this time, and these 2 points lie on the line of a linear equation, and we want to know what is that linear equation in slope-intercept form? What is that line? Just kind of showing you what it would look like visually. Don't write this down, I'm just kind of showing you. So 1, 3 is about right here, and then negative 3, negative 5 is about right here. So if I had 2 points, which are these 2 points given, and I knew that those 2 points were going to form a line, we want to know, well, what is the equation of that line? So there's actually a procedure that we can do to figure this out. So personally, when I look at this, I think, oh, I have 2 points. If I have 2 points, I can find a slope. So I'll have my slope of my line. So let's go ahead and use our slope formula. x1, y1, x2, y2. And I'm going to go ahead and say, all right, m is equal to negative 5 minus 3 divided by negative 3 minus 1. So that's negative 8 over negative 4, simplifies down to 2. So the slope of my line is equal to 2. That's some golden information there. We need that. Now, let's go ahead and use that method that we used in that first problem, because I have a point and I have a slope. I'm going to go ahead and use this first coordinate here because it looks easier to me because it doesn't have any negatives in it. And I'm going to go ahead and use y equals mx plus b. And here's my x and here's my y. So let's plug everything in. 3 is my y, 2 is my slope, 1 is my x, and I'm looking for my b. So 3 is equal to 2 plus b. I'm just solving for b, solving for b. There it is, b is equal to 1. If I have a slope and I have a y-intercept, I have a line. So y equals 2x plus 1. This is the equation of the line in slope-intercept form that passes through those two coordinates above. Okay, I have one more thing for us today. And this is going to kind of take us back to what we learned about back in Unit 2A with literal equations. The directions here say transfer the equation into slope-intercept form, then graph the line. I have two equations here that are not in slope-intercept form, but I want to graph the line of this equation. So I need to transfer these into slope-intercept form using my understanding of how to manipulate an equation around, which I learned when we talked about literal equations. So let's go ahead and start this one. I'm going to start this first one by distributing. So I'm going to say, okay, y plus 8 is equal to negative 3x plus 9. Now, remember, I want to get it in the form y equals mx plus b. So you got to kind of think about how I want to manipulate this around. I already have my slope in my my slope in my x on the right side. Let's go ahead and move this guy over to get him into our y-intercept. You'll see what I mean in a second. So now I have y equals negative 3x plus 1. You see what I did there? Now the equation is in slope-intercept form. And what can I do now? I can graph it. You can see here that my slope is negative 3 and my y-intercept is positive 1. So I'm going to go ahead and graph my y-intercept. And then my slope, remember, this is going to be negative 3 over 1. So negative 3 over 1, and I'm just going to go ahead and continue that pattern all the way up and down my graph on both sides. And then I'm going to go ahead and connect them with a line with arrows at the end. And there you have it. Let's look at another one. Notice it's not in slope-intercept form, but I want to put it into slope-intercept form. So the first thing I think of is getting the y on the left side and getting the x on the right side. So let's go ahead and start with the x. I'm going to subtract 4x from both sides. That's going to move it from the left to the right, leaving me with negative 6y is equal to negative 4x plus 12. Now, you might be wondering, well, why did she write it like that? Think about what we're trying to make. We're trying to make mx plus b. So I just put my x first. And you can do that because of the commutative property. Now, let's get the y by itself. We're going to divide both sides by negative 6. Now, this is a little tricky. This side's pretty easy because the negative 6's cancel out, and I'm left with y. But this skill we learned back in Unit 1. And here's the skill. We're actually going to be taking this right here and dividing it. So negative 4x divided by negative 6. That's going to give us 2 over 3x. Then we're going to take the other piece. So the positive 12 divided by negative 6 gives me negative 2. And there you have your linear equation. So you had to use some of your literal equation skills to get here. My slope in this case is 2/3. My y-intercept is negative 2, so let's go graph it. Here's negative 2, and I'm going to rise 2, I'm going to run 3. I'm going to rise 2, I'm going to run 3. I'm going to go in the other direction as well. Rise negative 2, run negative 3. Rise negative 2, run negative 3. And I'm going to go ahead and draw a nice line through all those coordinates with little arrows at the end, extending it in both directions. All right, that brings us to the end of our lesson on slope-intercept form.